Hi guys, 恭喜發財啊! This is the first video that I make to help you learn the last two chapters. So I remember I have already given you these notes, right? So if it's still review, you can take it out and then we can go through the blanks together. And this one, as I said, is quite different from the previous few ones because you don't have to study the mechanism of the reactions, but still I will let you know a very simple mechanism that can help you to understand the reactions easier later. Okay, now so if the notes is still review, let's just fill in the blanks together. I believe that you have already learned quite a lot about these three homologous series in the IGCSE curriculum, right? So basically quite a lot of content overlapping, so we can go a little bit faster. So alcohol are organic molecules containing the, I believe you know the answer, right? It should be hydroxyl group, right? Hydroxyl. As I told you, hydroxyl is different from hydroxide. Hydroxide ion contains a charge, okay? This one is covalently bonded, normally it's bonded with carbon, okay? So it doesn't have any charges. So now, and then, similarly, when you compare alcohols, it's quite similar to halogenal alkanes. It's also divided into three types. They are the primary, secondary, and tertiary. Okay, so how can we distinguish them into different categories? We basically look at the carbon that is directly bonded with the O of hydroxyl group. Okay, when this carbon has two hydrogen atoms, then it is a primary alcohol. Okay, and likewise, when this carbon has only one hydrogen atom, okay, then it is a secondary alcohol. If this carbon that is directly bonded with this O has no hydrogen atom, okay, then it is tertiary alcohol. Now, the reason for us to know down different degree of alcohol is that when they undergo oxidation later, they will give out different products. So that's why we need to know whether they're primary, secondary, or tertiary. Okay? 好。The alcohols have what boiling points than expected when compared with other organic molecules with similar relative molecular mass. Even methanol is very small, it contains only one carbon, right? But we know that it is a liquid at room temperature, which means that its boiling point is pretty high, right? And I bet you should know the answer, right? After learning intermolecular forces have higher, right? The reason for that is alcohols, they can form hydrogen bonds among each other. So that's why a greater amount of energy is needed to overcome this stronger hydrogen bond. Now, I'm not going to write every single word. So I will say the alcohol, right? They can form hydrogen bonds, right? Between molecules. Remember, you have to mention the types of the particles when you are describing the interaction between particles or atoms or molecules, right? So that's why you need greater energy, okay, to overcome it. Okay? 好, draw a diagram to illustrate how hydrogen bonds arise between ethanol molecules, okay? So how can we do it? As I told you a lot of time, there are several things you have to bear in mind when you draw formation of hydrogen bond. First, you need to show the lone pair. Can you see that? Lone pair. Then you have to show the partial charge. Can you see that? Then this one will be linked with the hydrogen atom of the other ethanol molecules. Okay? So this will be like that, and then you use dot line, and then you label this intermolecular force, hydrogen bond, okay? Now, I think after showing you this picture, you should be able to draw the hydrogen bond formed between ethanol and water molecules, right? Can you draw this one and then send me your picture? Okay, let me see if you missed anything. Okay, individually. Okay, I know you. I believe that you know how to send me files individually, right? Oh, ethanol mixes with water in all proportion, but hexane-1-no is less miscible with water. Why is this? Now, this is actually what I told you in the class before, because if you ask me whether alcohols can dissolve in water, I can't give you an absolute answer because alcohols contains two parts, right? This is the hydrophobic hydrocarbon part, right? Okay, and this is hydrophilic. Now, hydrophobic means hater, right? That means this group doesn't like water, but this group likes water. What I want to say is that if this group is very big, if it contains a lot of carbon atoms, then even though these parts can form hydrogen bond with water molecules, the whole molecule as a whole cannot dissolve in water. So hexane-1-no, as you know that it contains how many carbon atoms for hexane-1-no? 6 carbon atoms, right? So, but ethanol contains only 2 carbon atoms, right? So basically this part is pretty long. The hydrophobic part is pretty long. It makes the whole molecule cannot dissolve in water. That's why it is less miscible with water. Remember, you cannot say, oh, alcohol can or cannot dissolve in water. You have to take two factors into consideration. The first one is how big the hydrocarbon part is, and the second part is how many hydroxyl groups it has. For example, propene 1,2,3 triol has 3 hydroxyl groups. It makes it very, very soluble in water as it can form very extensive hydrogen bond with water. Okay, this is the first page. Now I'm going to divide the video by pages because I can't upload a video with such a massive size on the SATA. So let's just take a break. Bye. 我點停啊？